Cool. So nice to meet you. Thank you so much for being here with me during this morning, afternoon, or night. I'm not sure where you are based right now. My name is Felipe Pires. I'm based here in Portugal. I'm Brazilian. And yeah, so when I look into this way here, because I'm looking the screen for everyone here. So if you have any questions, I'm not sure if you can type in the chat or like if you can just raise your hand, or if you need any questions, like I'm looking my right side here. So just to let you know if you have any questions during our conversation, okay? So today, basically, I will walk through this malware analysis stuff and how you can using this for the adversary emulation perspective. So I wrote this article last year when I analyzed one specifically PDF malicious, and that's the idea for this webinar today, just to share with you guys how we can combine those things, how you can bring this realistic in one side, or I mean, this real malware to the emulation side. Okay, cool. But probably, or actually first, who am I specifically? Now I changed my company. So I was working in another company previously in my last webinar that I made here in iExperts. And now I'm head of technical advocacy at SCYTHE. Basically, SCYTHE is the best solution, best platform, which is a breach attack simulation platform. And our platform is as well focused on adversary emulation, AVE, adversary validation exposure. So basically, our main idea is to just, and three pillars when we create this platform, is just to democratize the red teamers. And the second one is to assembly new threads. And the third one is to bring this thread or this emulation more realistic as possible. Basically, I'm responsible for bringing these technical things and to be one of the advocates in terms of product and helping some areas in the company, which is in EMEA region, which is Europe and Middle East, and as well APEC, and like Latin America, because I'm Brazilian, I speak Portuguese and Spanish, and US, in this case globally. But anyway, so that's my role in this organization. So I founded an investor in this company, which is Cross Intel, responsible for helping organization to cross different markets. So I helping companies I want to grow. For example, if they are headquarters in Brazil, they want to grow in Europe. My company helping to do that. If they based in Portugal, they want to grow in Middle East. My team can help you guys to do this. And I'm advisor investor / partner in this specifically product, which is Sherlock AI, more focusing on OSINT, which is open source intelligence. And this is my involvement in terms of product and business. On the other hand, I'm very active in many different communities, which is I'm organizing a leader at B-Sides Porto, and I will talk after very briefly. And I'm director of the Red Team Village, one of the most respectful village at DEF CON. So I'm part of the team and the core team. I found this Red Team community, which is focused on offensive security and helping guys, or let's say the new generation, to grow this kind of Red Team skills, how they can improving these skills. And I'm supporting and I'm the advisor in the education perspective at Raíces Cyber, which is focused on Spanish people or Hispanic people, let's say, and Brazilian guys, and helping those people to get inside of cybersecurity. So that's my involvement in the cybersecurity. So basically, which is besides Porto, as I said, so I'm based here in Portugal, very near than Porto. We are launching our second edition, which will be happen in June 27th. So if you are near here, or if you'd like to participate, just come to us. You can access our website, which is bsidesport.org. You can see we have call for everything opened, which is call for paper, call for village, volunteers, sponsors, and it's the conference for we expecting 700 people during the second edition. Cool. So just briefly things about me. So let's talk about our main topic today. So first, just very fast, very briefly. I mean, these conversations we divide in two parts. One is more theoretic part. I know sometimes it's let's say not good thing, but it's necessary. And after that, I go to more the technical perspective. Okay, so basically this is the flow usually I like to share with my students. By the way, I'm professor in master degree here in Portugal in a university called ISP Gaia, which is next to Porto. And one of the things that I guiding my students is, okay, when you receive a kind of artifact or sample, so what is the main idea about that? So how you can, let's say, investigate that, how you can, doing the proper research or reverse engineer. So first you have the maldoc or malware, which is malware, malicious software, and maldoc, which is malicious document. And after that, you choose what is the best methodology that you can apply, or you talk after. And when you analyze or when you decide what is the best methodology to use, which is a statistical analysis or dynamic analysis, you can use preparing a proper report. Because when you do a report, you can create a proper article, for example. Of course, if you need anonymize sometimes some informations, you can do that. But it's important to design everything, because when you do a kind of investigations, you can design step by step, use it by the attacker. Remember, we are designing how the attacker are thinking. Even if you are doing let's say, a defensive side, you are analyzing for the malware analysis, which is more defensive perspective. When you describe everything, you can see how the attacker, thought about that attack, and that okay, if they using this and that techniques to bypass specifically security sensors, so that's the way that I can create a proper, let's say, attack for the offensive perspective. And not only that, but you can improve defenses mechanism for the defensive perspective. You can support in the CTI, which is cyber threat intelligence. You can build that, and you can be more like, let's say, you can strengthen your cyber resilience when you talk more in the manager level, let's say in the leadership level. Okay, cool. What is statistical analysis for your first time here? Basically, it's the first step using the malware analysis. Why? Because basically they describe the process or the what kind of code you analyze, what is specifically the structure, involved with that. So if it's important any DLL or any libs, for example, how is important, what kind of a function is important or is important. It usually is more in double quotes, it's more safe, because you doesn't run exactly the binary in the real time. It's just using kind of tools or type some commands, and they bring some results to you, and you can, let's say, interpret these results. Okay, cool. On the other hand, you have the dynamic analysis, which is more based on behavior. It's simple like this. You put in the malware doc or malware in specifically placing or in specifically tool, that you bring it to you a kind of results, okay? And sometimes, of course, you can automate this process. Sometimes, not sometimes, but usually they call it sandbox, which is the proper environment that you can put in this binary inside of this, and you can explore this inside of this specific environment, which is sometimes the virtual machine. And this virtual machine will bring to you the result if this exploit, let's say this is blue ball, is the malicious artifact. This is malicious or non-malicious. It depends on the engine inside of the sandbox. If you don't have any engine inside of this specific sandbox, it's just like a virtual machine. Of course, there are kind of other tools that you can just run in the malware, and they can stop, putting kind of breakpoint, and you can see step by step. You can disassembly this, and maybe when I talk about this assembly, think, okay, what is exactly reverse engineer? It's basically the technique that you reverse every single binary that is saying, let's say, to open this specifically binary. So you can stop and go and moving forward in this analyze. But of course, to do that, you need to understand more about the assembly, programming language, and not only that, but it's a kind of technique that you can use in both methodology, which is you can use in reverse engineering, dynamic analysis, and in statistical analysis. Okay, cool. So why PDF are the preferred attack vector? That's is interesting about this specifically article that I wrote, and this is specifically a webinar that I'm doing right now. So 80% of these organizations, they receive many malicious. So it's just there's just two simple use case and here. So if you have a financial team in your company, you know that financial company will receive many invoices per day. On the other hand, on the flip side, you have, for example, the HR team, which is the team responsible for receiving many resumes or CVs. And probably you are listening right the webinar, and probably you send your CV or you would upload this on LinkedIn platform, for example, or whatever platform you use. So it's a PDF. So that's the day by day of this team. Okay, so because of that, it's keeping doing this, the attack vector used by the attacker. And for example, and this is specifically malware that I will analyze today is based on specifically, they have a 20 objects embedded inside of the PDF. I will explain more in details step by step after that. And usually when you try to figure where is the malicious content inside of the PDF, usually we need to look into where is the amount of bytes inside of this PDF. So let's see the real world scenario case here. So an HR manager receive a PDF resume, as I said, from an applicant, which is me, or even maybe you or your cousin, whatever. So the file looks like legitimate, which is like, okay, it's a resume, okay? So even it shows a professional layout, but the moment they opened the Adobe Reader, which is the application responsible for open this PDF, let's say my blue ball, this is the PDF, they will open this, okay? So imagine the obfuscated JavaScript executes silently in the background, so behind the scenes, okay? Allocating memory, injecting shell code, establish the connection with the CNC, which is the command and control from the attacker, which is this IP address from Netherlands, okay? So that's the real world scenario case here, okay? Primary targets in this case, HR department, finance teams, legal teams, and executive assistants. If you see, this is the normal user that they can use in this, they can open a PDF, okay? Cool, let's understand more about physical and logical structure about PDF. So usually the PDF has 4 parts, which is the header, which is body, cross-reference table, and trailer. This is the main 4 parts. Usually the header is the version that you can use in Adobe Reader to open this PDF. It's like one of these platforms that can open, of course, there are others. And we have a body, which is page, objects, and font. We have a cross-reference table, and we have, on the other hand, we have a trailers, which is certain locations between one specific object and another. So basically, the structure of PDF, they have a 3 structure, as you can see in this picture, which is the number 1 is, let's say, the father. Number 2 and 3, both of them are child or children of this guy, okay, number 1. And if you see here the number 4, he's a children or child for this number 3. So if you see here the number 2, they don't have any children, any child, no one, nothing. But on the other hand, this is number 4. He had 3 kids, let's say, number 5, 6, and 7. So that's the way that PDF works, you see? So in the 3 architecture, let's say, okay? Cool. So behind our PDF, there are a bunch of information we can try to collect. One of these is page, which is how many pages the PDF have. Usually for malicious perspective, it's just a one single page. And we have an encryption, which is the parameter to check, or you need to have a kind of password to decrypt this password. We have an object stream, which is an amount of objects that you can compress inside of one single object. I will explain more in technical details soon. So basically, this is important to understand. So sometimes you just have, let's say, 10 objects, but if one single object, so if you have one single object streams, can be possible to have more than 100 objects inside of this only one object stream. Why? Because it's compressed. Okay. Cool. Let's see. When you see, for example, JS or JavaScript, its basic elements usually is the high risk because it's not a normal behavior to using, let's say, JavaScript embedded in the PDF malicious, okay? When you have an EAA or open actions, it's basically when you have a specifically action behind the scenes happened when just the user view a PDF. It's as simple like this. So if you have this combination like, okay, JS and JavaScript and open actions, it's terrible. So basically you are, let's say, I cannot say this because it's not polite, but you are in trouble. Cool. And if you have a acroform, basically is the interaction of the many elements, and sometimes you have a kind of a script running using this acroform embedded in the form when you need to fill out something, or you can use them as well for, let's say, for info stealers when they want to collect information using those forms for you. Okay. And the last but not least, we have a streaming page, which is essential. The possibility to compress encoded objects, or it usually is the part of the attacker using some kind of JavaScript embedded to put in inside of the streaming page. It's basically how you can pick many, let's say, objects embedded, and you can compress on one single page, and you're just putting inside of your PDF. Let's go to the more technical things, just to share to you the two difference here. So I'm supposing you are seeing my virtual machine right now, okay? See if you can confirm me on the chat, if you can see my CLI, which is my command line interface. Can you see my screen right now again? I'm sharing something. If someone can type in the chat, please do that for me, just to understand if you can see my, let's say, CLI. You are seeing the black window here? Yes, no. If you can put in thumbs up, I'm not aware if you can do that. Yes, thank you, Jenny. Thank you so much. And like I have here a bunch of files, and I'm just looking directly to the PDF, okay? So I'm going to this specifically here. I'm just very quickly compare 2 or 3 PDFs. So just if I put in here, for example, just to confirm, file, store PDF. If you see here, it's a PDF document. And if I type, for example, PDF ID dash store, you will see, for example, how many objects. Remember, I explained to you the structure. Remember, they have a header, which is over here. They have a body, which is the bunch of objects that you have. They have a cross-reference table, which is this one here, and trailer, usually when you can find information about the root file, which is the big father in the tree structure of PDF. Remember that? And remember the slash page. In this case is interesting because they set a 0. Let's say encrypt 0, but they have, as you can see here, one object stream, which is funny because in this specific example, we just have one single, but 18 objects. So let's see, for example, PDF ID. I have a friend here, which is a Bill. Bill is over here. So if you put in PDF ID, I forgot D. Okay, now it's okay. So if you compare this specifically PDF, they have 44, which is bigger than the first one. Remember, Thor 18, this one here has 14, which is almost 3 times than another. So, but in this case, they have 8 streaming against, for example, 16, which is the double of streaming. Remember, which is streaming? Is possible embedded something. Remember, when I have a stream page, it means that I can embed something. Sometimes JavaScript, sometimes is another things. What kind of another things, Philip, I can put in there? We can put in, for example, let's say just image, let's picture, for example, or let's say whatever your creative can use. Okay, cool. But in this case, for example, Thor, we just have, let's say, object, one object stream. But if you go to Bill, they have 0, which is no one here, nothing here. We don't have any, let's say, open actions, no JavaScript, no AA, no nothing, okay? So if we go back here to Tor, let's say we have one open action, which, let's say, can be cool, but we don't have any reference about JS or JavaScript. So you see, this is basically the comparison that we can do that. So let's say, so another very interesting thing is if I use, for example, PDF parser, another command using -A, for example, -W, which is the raw data. I'm just trying to see the Thor. I will put in pipe here, which is this command. Pipe less, which is I would like to start since the beginning. And this is specifically this file. What I'm doing that because basically my let's say my terminal, okay, is the buffer. The information that you can read here is small. So just because I'm using less, okay. So how here, let's say this parameter, which is W, which is raw data or raw code. So as you can see here, this is the structure that I mentioned earlier about the tree structure, okay? So we have an object 2, which is the father, and those referring or references are child or children or kids. This guy, this guy, this guy, this guy, this guy. They are inside of this family here. So they are linked, as you can see here. If you go below, let me go to below here. Let's see, contain streaming object 12, which is interesting. So when you see this flat decode, it means that you need to decode something. But what thing I need to decode or decompress is basically based on something that are inside of this object, which is streamed. why is streamed, or no why, but what kind of information is streamed. Here is the left, the information that I can see. I cannot see nothing. I mean, we cannot see exactly what information you can see inside, but you can see the left, which is 10, like just small thing. This another one is 10 again. This another one is 10. Object 12, 15 is 43, 53, 55, 53. Here, as you can see, containing string, but they referring another two more. Remember, 29 and 30. And if you go below here, take a look. This here is flat T code. However, if you see here, the subject type is image, which means that it's not a JavaScript, it's an image. So that's the point, because the left is very big. Maybe you think, okay, if a stream is the part of the malicious content, I should look into that. But once you look at, let's say, this is the image, of course, can be using the steganography technique, but I'm just trying to see, doing this investigation with you guys right now. So here's the same case, another image, another big left, and another image here, and then a bunch of them. Here can be something different, like objects 28 embedded file, which is very interesting. And this number is very cool, because here is the point, or here is the, let's say, the way, or something that I should look into deeply, the object 28, because the left is big. We have a flag here, which is flatted decode, that I need to decode this specifically. It is information which is the embedded file. So maybe I can find some exploit here. So I should focus on this here. Here is another thing. So I have an image, flat decode, the left is small, but here I have this other reference, image. So if you go below, there are a bunch of other things here, like flat decode, but here is the image. Here, interesting, the object one, which is normally should be starting from the beginning, but in this example, not start at the beginning, it's starting in the middle of the whatever place. Okay. And the interesting point here, guys, is like object one, they referring another object which is 35. The interesting point over here is, here we can see the object streaming. Okay. And here, let's say embedded here, which means that, okay, the object stream is embedded in the object one, and they referring the object 35, which is this one here. So object 36 vanish here, and here is, let's say, the root file, which is the number 2. Remember when in the beginning? So if you go since the beginning over here, this is the object root. They started for number 2, not for number 1. So let's go to the end again. And here, as you can see, the cross-reference table, and we finish here the whole document. Remember, this is simple, like, what is the document here? It's Thor. Remember, to just type it again, then I go to the end, just to share with you something interesting. Can you see here, object 36? Okay, cool. But when you're using PDF ID, for example, take a look what happened right now, or they should have just 18 objects. So why, when you use another tool, we have 35 objects? Because they should have just 18, not 30, 35 or 36. But the answer is over here. So if you're using, for example, PDF dash parser, for example, dash A, which is the object that I would like to look into, or how is divide this, and here is the answer. So it's really 18 objects. However, remember, the object one is when you can find in the object stream. Is that correct? Yes, we saw that. Cool. So in the end of the day, they have many objects compressed. Remember, embedded and my explanation, the third part. So that's the key here. So inside of the object one, which is this one here, I have the object stream, which is plus 17 objects, because if I just have an 18 plus 17, what is the number? 36. Is that correct? I'm not good in math, but I suppose that is correct, okay? So you have, let's say, 18 objects indirect, which is here, and plus 17 objects let's say, directed to that object stream, which is this one here. So this is the way that you should analyze many different PDFs. So basically, this is a malicious PDF. The other guy that I showed, the other guy here, Bill, is a malicious as well. So in this case, they don't have any, let's say, object stream. Just to show you the theoretic part about the difference of those two PDFs. Okay, cool. Let's go to my main PDF. This is the main PDF. Let me go to the SCYTHE PDF. And here is the new. I think it's new. Yeah. Cool, 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 cool. I have here. Let me just see. It's resume. It's resume. It's resume. I'm just checking here, guys. What is the sample here? Okay, it's resume. It's not CD. It's what's the command? PDF ID resume. That's our file. Okay, they just have 20 objects, and you have a 6 streaming. We have one trailer, one page. We don't have any, let's say, object stream here. It's 0, and we have in a minimum 5 reference. It means 2 of JS and 3 for JavaScript. You have one open actions and another one acro form. So we should look into where is the malicious content here. Based on that, let's go to the PDF parser, for example, PDF dash parser dash A. What is the name? Resume. Cool. So usually when I make some kind of, let's say, analysis, this is the step-by-step that I'm used to use in this kind of analysis. So usually PDF ID, and after that I go to PDF parser, sometimes -W, just to see the raw data, the raw code, to see everything. If I cannot see anything more, let's say something that, let's say, fix my attention, that I go to this another command -A. I'm just putting PDF dash parser -H, just to explain to better here again. So -W is the raw data, raw output, and that of, data and filters. And the other one is stats of display stats for the PDF. They look into the, let's say, the objects. Why I using that? Just because they can bring to me how they structure the objects, what is the kind of streaming that I can look into, and if they have, what is the objects content of the JavaScript here, what is the JavaScript, and where I can find the open actions over here. But if you see here, maybe, okay, you think, okay, I should look into the object 7. So if I just put in, let's say, -O and 7, O, which is the object, and I type here, this is the reference, this is the information, which is the, what is the reference in object 7? Open action, remember that? I should look into that. Okay, here is the reference. In object 7, I have an open action, which is totally used by this JavaScript, which is something, but the JavaScript is not here. But the open actions is, let's say, is related to, in terms of flow, think about open actions, and after the open actions running or launching the JavaScript. But the JavaScript is not here. Why? Because if you see here, object 7 referring other bunch of objects. So I should look into the object 8, 9, 10, 11, and so on and so forth. However, well, let's say 8 is not here. Okay, if it's here, 8 it's here, 9 it's here, 10 it's here, 11 it's here, and 12, for example, it's is not here. So I don't need to look into object 12, and 13 is not here. What does that mean? Basically, this is the streaming locations that I shouldn't look into. Okay, and that's referring about some this is not a streaming, sorry, it's a mistake. So here is the reference of streaming. But here, if you see, they don't mention anything about those objects. In this case, we cannot see any 1, 3, 4, 1, 3, 5, 6, 17, and 19. So this open actions is related to something, but I need to find where is the flow until get this specific object. Okay, cool, nice. What is the next? Because we should look into, let's say, this one here and go step by step. I know that's sometimes kind of complicated. Let me go to simple like this. Let me go to -W here. And I'm putting, well, again, resume slash last because of the reason that I explained to you. Let me go to, this is the root file, referring number 2.4. Remember, object 7, our main goal here. Object 7 over here. Object 7 referring object 8, 9, 10, 11, 12, and 13. That's moving forward. Okay, referring, this is the information we got. And now it's moving forward for object 8, or maybe, what is the object? Yeah. 8, 9, 10, 11. Let's see if we can get this. We don't see any, let's say, order to follow. Okay, let's keep walking. 11, 12, 13, referring another 2, because we have another reference. Nothing about streaming. 8 is over here. You see the order is completely opposite. So 8 referring nothing, 9 referring 16. So let's see if there are kind of thing in 16. 15, it's here, just text. And if you go to object 14, they referring another ones here, but nothing about streaming. Nothing about streaming over here. Media box can be like a box in the PDF just to fill out something. Who knows? Object 7 contain the first stream that you can see here, which is the left is small. Object 18 referring 918. Oops, here we can stop. Maybe we can auto pause here. Let's say JavaScript in object 918. So we should look into the object 918. So if we go to here, oh, we have a stream here, and you have the left bigger than others. And here we should decode. And if you go to an object 20, just keywords, and here close, finish. Usually when you find this, let's say string, it means that it is finished the PDF. So this is the main goal here. Now we should open to this. Okay, let's go back to our basically our presentations here. So here the structure that we have in this resume.pdf. So we have a header, we have a body, 20 objects, we have a cross-reference table, and we have a trailer, which is object 7, the catalog, the point of the thing. And if you see here, object 19, it makes sense because when you saw here, this is our, let's say, information that you should look into. Okay, and this is our payload. They are here. Here is the step that I shouldn't look into. Okay, key objects using PDF ID, as I said, 5 instance, the high risk. We have auto executions of open actions, object stream. Sometimes they can hide in payloads. We don't have anyone in this here in this specific, but we have an acro form, which is interactive form with the scripts. In object 19 is the size of bytes that you should look in, and plus flat decode, we should decode. And we have our information about Netherlands week there in the future. Cool. So I typed this comment to you, and I did the same here. I explained to you. This is just to let you know the same comments that I made. I just print in here. So this is the interesting thing about, well, we can do that, let's say. So for example, we can use in different tools to do that. Let's say, for example, PDF-parser-O, which is, I mean, let me put in here in this case. So if you go back here, some commands, okay, version help and -f, which is a string to search an indirect object, accepted streamings, pass streaming objects through filters for flat decode and ASCII decode, ASCII 85 decoded, and LZW decode and other things trying to decode something. So you should put in -f in the end. So if you see here, let me just put in PDF-parser-O, the object is 19, the resume-f. And if I will put in pipe less just to guarantee that you can see here, because I know the content is very big. So here is, let's say, the decompress, the decode, because we set the command -f. Okay, so if you see here, this is the JavaScript obfuscated. Here is obfuscated. So we should disobfuscate it here. But how we should disobfuscate it? How? Because we can see this parameter here, which is equal to something. Here is another command, equal to something. And if you go back, so let's see if we can interpret something. Or here we can see something similar, let's say. So here you can see some kind of parameter, and here is the same sequence of letters. Maybe they can see something here related to. Here is another thing. So we can see here this name, the same word. And here is the same word. You can see the familiarity. And here you can see the other parameter or word, like this one here, I mean, this one here, this one here, and this one here. So they are related to something that I should interpret. Okay. So if you go back here, so take a look. This exploit is very big, and finish here. But there are kind of interesting things when you look into more in details. If you see here, there are kind of thing that you can check here, which is this specific parameter here. They appears to us many or several times, as you can see here. If you see very fast, you can maybe confuse it like the WhatsApp, but it's not WhatsApp. It's just a confuse words. Okay. And all the other things that you can see here is this between parentheses. It's very interesting because they appears to us in a very single way, numbers, letters, and percents. Okay. So here we found this. Okay. Once you do that, when I did that, I need to decompress those information inside of that. Okay, I did that. So let's try to, let's say, identify something. As you can see here, the GKPH key, the word, they have a string basically splitting, which is the many variables hold fragments, and you have the obfuscations, which is the evil, in double quotes, evil parameter. And sometimes we can find the evil, the name, the word evil. But in this case, we didn't find any evil. We just find this, let's say, HYLTL. This is the evil parameter assigned via array index strict to evil, as you can see here. You can see the string reversal, which is this kind of WhatsApp. I will call it WhatsApp, but it's not WhatsApp, okay, guys? It's just a similarity when you look into. And basically, this is the reverse encode streaming to reconstructed JavaScript code. As you can see here, the reversal. So I use in my article, I published this in the labs.doc, Segura.doc blog. We can see the whole article published in there. But basically what I did was the reversal, I was using this parameter to reversal using Python script, okay? And Python decode this description. So basically, the step that I did here was, okay, identify functions calls, looking for any calls functions like the evil that as I said, breaking down the string and what kind of concatenation they used, which is this GKPH key, which is this one over here, or this one over here, and this were more. Let me just check in the virtual machine. Let me just go in the beginning here. As you can see here, over here, or they close over here. Actually, this code is separated in two parts, and I will explain it here right now. So if I go here, this is the first part of the code, okay? So as you can see over here, is GKP is the first part of the code, they finish here. And here, how I, using Python scripting to decode in the reversal way. Remember that as I explained over here to you guys, using this string to reverse the string reverser to reverse this kind of command over here. Okay, and I found these results. And the second one is the second part of the code is over here. Remember, as I said, WhatsApp, no WhatsApp. You see, this is kind of similarity. And between those parentheses, there are some kind of important thing here, which is the payload here. The payload here, they are using the Unicode technique, which is in 2 bytes, different of the ASCII, which is in 1 byte. Okay, cool. When I decode these here, you can find the information about array, about where is the exploit, which is over here, below collab.collection email info, which is the vulnerability using let's say published by Adobe in 2007. And when I did that, so if you see here, the unescape, so here is the information, this unescape is the information of the real payload, which is, so I will explain the flow after, but like this is the payload responsible for downloading the victim machine. This payload will be responsible for communicate with the CNC. So I basically copied and pasted this here in this another platform, which is Mozilla, and I put in here, and I basically convert this Unicode that was in UCS2 to basically hexadecimal. When I did that, I have this specifically information over here. Let's say converted, and after that I let's say convert in hexadecimal to binary, because this block bin is basically the binary responsible for installed in the customer or the victim machine, let's say. Okay, and after that I use another tool called short search, which is from DDA Stevens. Bunch of tools that I'm using here, the most part of that is from DDA Stevens. Okay, and I tried to collect this HTTP, which is the CNC. Remember, when I put in the locations hidden CNC, this command and control CNC is from this IP address is from the attacker. So that is the final callback. When the victim click to open the PDF, they will receive these connections in Netherlands. Okay, so here how everything works. This is the exploit chain, and this is specifically attack. So when the user receives the PDF, they will open the PDF. Open action will be triggered by JavaScript automatically, as I said. Okay, they don't need to click just for view. They don't need to click twice. Just when they open the PDF, they are running behind the scenes. After that, the step 2 is memory allocation. So this is the size reserved to run or to launch this exploit payload. The malicious guy, when they create this attack, they put in this specifically buffer overflow to slide execution to the shell code. And after that, they're using this parameter here to fill out this NOP plus shell code, repeating to infect the whole things. And of course, to do that, they need to use this specifically exploit, which is the Adobe API exploited, registered by this CVI ID. And after that, they communicate using, as I said, Unicode to talk to the CNC and the reverse engineer. This callback with the command and control, the whole flow about this specifically attack. So basically, here is the information. So it's a JavaScript API method in the Adobe Code Reader designed for document collaboration. Attacker exploit these functions to execute the heap spray attack, overwrite the memory because they need to put in this, and achieve the arbitrary code executions. All triggered silence because they are using JavaScript obfuscated. When the victim open a PDF, as I said, the shellcode is encoded in Unicode, as I said to you guys, using this escaped sequence percent number and ladders. This is the format of the unscaped. Okay, and after that, we did the whole analysis. I did, and I spent many hours just to convert this here in few minutes. But basically, we saw the whole step by step. So how we can emulate these attacks. So here, how you can see using, for example, the mapping, the malware behavior using this MITRE attack here. So here is the spear-phishing attachment usually. So this is the behavior when you're building something to simulate the similar attack. So basically using this TTP, basically this technique, using the initial access, which is using the spear phishing, for example, and a specifically target that you have. So using the resume PDF delivery via email to HR targets, for example. And after that, just the execution process, which is the JavaScript running. As I said, when you trigger the open actions, they will be obfuscated by JavaScript for file open. Diffusion evasion, there are two techniques here. One is specifically obfuscated files, they are using, for example, the reversal variable, which is this evil indirect using this reversal thing to disobfuscate it, which is not normal because they're using this to bypass, which is the defense evasion. They use, for example, to emulate this, we can use in the process injections, which is the shellcode injected via for example, heap spray plus NOP slide into the Adobe Reader, the proper exploit, which is the Adobe Collab, and the last layer, which is the CNC, which is the CNC beacon to communicate the object file here, okay, to hiding the Unicode. The IP address was, remember, the IP address was encoded in Unicode, remember that? So they use an escape to be encoded. Because of that, is hiding here. Okay, and how you can build in this using, for example, SCYTHE as a platform, but you can try to use another platform, but it's just a reference about SCYTHE, for example. So one of the ideas is to import this specifically TTPs from our perspective, just to building this campaign, for example, the scenario using phishing, PDF executable, lateral movement, and CNC. You can deploy kind of implants, or let's say the agent or agentless, or whatever name you can call. We call basically this is specifically implants, which is the agentless, execute the campaign and collect the results. Why we simulate this? Because we understand, for example, in the SCYTHE perspective, that's real to simulate the realistic, as I said in the beginning. We can building this using, for example, attack framework or MITRE ATT&CK framework. All those simulators based on the real evidence or real results, and you can do like a purple team exercise to track that, helping the team together, let's say putting the auto pause, for example, to helping them, to supporting them with the, let's say, activities in terms of, okay, no one detection this kind of, let's say, JavaScript when they launch something. So let's pause this campaign here and let's see what is the instant response team running after that. And of course, we can repeat the campaign just to see everything. So just to closing everything in terms of collaboration teams. So we have a red team in one side, attacking using real TTPs, which is tactical techniques and procedures. If you're not familiar with that, I recommend to read this any article. You can go to, let's say, in the SCYTHE website, in the platform website of SCYTHE to see any information. You can reach me out if you have any questions about TTPs. I can explain and help to you after. But basically, it's tactical techniques and procedures from my MITRE ATT&CK framework. We can run, for example, purple team engagement or actives, and you can use it, for example, blue team to improving that, to working together. Those three teams is very important. Here, one way that you can use it, for example, the global metrics, looking to, for example, email gateways to block, to try block attachment for, let's say, mitigations, IDRs and antivirus for obfuscated JavaScript not flagged, memory protections, which is against hip sprays or something like in this specific techniques blocked by deep. Network IDS, which is detection, or maybe network IPS, which is prevent, to block CNC traffic, and Adobe Reader for specifically patched Adobe solutions sometimes. And just to finish here, the takeaways is PDF are trusted sometimes. I mean, actually, the attackers like to using that because basically everyone's, in terms of teams, they need to open a PDF. And at a mixed, they use a different mix about obfuscations and protection, using Python script, for example, to decrypting things or encrypting things to decode. Every malware sample is blueprint for adversary emulation. That's super cool because we can try to simulate the whole flow. Remember the first slide that I present to you, the flow? When you describe your research, you can simulate that. Remember that, okay? That's very important. And when you're using this for MITRE ATT&CK, using the MITRE ATT&CK breach to analysis in this real world is very interesting, and trying to pushing your purple team together. If you don't have any purple team together, trying to pushing the offensive security teams and blue teams. I mean, offensive guys, defensive guys working together. Sometimes you are the only one, you are the lone wolf. But you can do that. You can do that if you want. I know that's difficult, but sometimes you need to try. And what is the next? For example, analyze our Ion samples. Try to using, let's say, tools like PDF ID, PDF parsers, and others in a controlled environment. Try to map this with the MITRE ATT&CK. Try to run the first emulation. You can use SCYTHE, or you can use another open source if you want. I remember that I open source a purple team framework that you can try putting purple team framework. GitHub, you can find in there. It's supported by SCYTHE, it's open source. You can try using that. Make sure and try to improve those gaps and try to read the full analysis. Okay, so I finished here our conversation. I hope, guys, that should be very useful for you during this webinar. And here I can share with you my contacts. I have here my LinkedIn, my Instagram, and I publish something there. And let's say my Twitter account. I have a few talks at the YouTube channel. Basically, the many things that is public, I put in there, and my GitHub that I have some open source projects there to share with you guys. And besides, port to LinkedIn if you want to participate with us or just follow us. Let me just see if you have any questions over here. 1 second for organizer with Leon. Okay, for organizations with limited resource, what would be the best starting points for implementing adversary emulation based on threat intelligence? That's a good question, Annie. Um, my recommendations to you is try to, let's say, sometimes is as important to not important, but when you don't have any, let's say, budget or limited resource, as you said, sometimes we should look into an open source initiatives. And of course, try to see the most open source, which is go to the GitHub and try to see those projects there and try to see how many stars they have. It's important to have many stars because it means that many people went there and they evaluate there, they use it, they are using that tool. As basically the way that you can implementing, let's say, adversary emulation using, let's say, threat intelligence is when you collecting IOCs, which is indicator of compromise after is a post attack or post exploitations. So when you collecting, for example, hash MD5, SHA-1, SHA-265, no, 256. Yeah, I'm translate something in my mind. But basically, you can try to simulate those steps using those IOCs. And of course, sometimes you can try to build this in another perspective using, for example, EOA, which is indicator of attack. In this case, you need to look in more how is or why is the reason that attack are doing that. So in your company, for example, so one of the guidance that I can do or can bring to you in terms of IOCs, one of the things that you can look into is look into MISP, the Malware Information Sharing Platform. This is another open source project. You can put in there many IOCs and you can correlate those type of things. And when you saw that, you can try to emulate something in your organization, okay? But of course, if you want to see more about the site, just reach me out after the webinar if you want as well. Let me go to another one. How can secure teams prioritize each threat intelligence or malware samples to turn into the emulations campaign? Cool. I think it's quite a similar idea about the questions, but basically one of the things is when you do a kind of analysis in terms of a mal or threat detection, for example, and sometimes we need to see the flow, for example, because when you emulate something like this one here, I'm just closing here. Sometimes what is the way that I can, for example, sometimes they try to, let's say, okay, let's suppose when you analyze something and you saw the shell script when you got the shell script and you saw the shell script, for example, and the shell script they type some command like, for example, name dash a, for example. So if you have inside of the shell script and the attacker putting this command, which means that okay, they are trying to look in what is the system operation here of the pushing, for example, host name. So host name. Okay, so they are trying to see something. So that's the thing that you try to see, okay, how I can see this and how I can helping the team. So how I can prioritize this? Basically, when you find something is critical for the business, so that's one thing that you can try to emulate. Or even another suggestion I can bring it to you, Herschel, if I can pronounce your name wrong, sorry for that if I'm pronouncing your name wrong. But basically, if you're working, for example, in a financial company, for example, and you saw and on any hacker news, for example, some Lazarus attack. One of the guidance is, okay, let me just see how is the attack happened, how was the TTPs used by the attackers, the techniques, tactics, techniques, and procedures used by the attackers. So how I can emulate this. So this is the way that you can prioritize, for example, what kind of attacks are happening in my business or the same business that my organization are into that. Let's say if you are working in an ICS company, what kind of attacks are happening right now in the ICS or OT? So how you can emulate that? So that's the way that you can prioritize your security teams. Because the first layer of defense is, okay, how I can create my own proper defense. So, for example, if your company just using, let's say, SCADA protocol, you are trying to protect your environment against HTTPS, but you should look into the protect your SCADA protocol. You know what I mean? So that's the main way that you can try to, let's say, creating or turning into the emulations campaign. Let me go to Patrick. In your experience, what are the most commonly missed attackers techniques that organizations fail to emulate during the security test? Let me just check in here. Uh, it depends, Patrick, actually, um, because I think it's the most. It's not exactly missed thing, but in my perspective, it's more like sometimes the teams or the security teams, they just has, and I said, sometimes the limited budget or resource, they don't use in their creative mind to emulate things, because they just working, let's say, putting something behind of your hands or your arm, and that's okay. I don't have budget, I just have, IDR, and that's it. But sometimes you can work more in creative way. What does that mean in this case? Okay, if we can see, let's say, the purple team framework as is free, so let's try to see how this works, how I can emulate that, and but I think it's the most problem in terms of defense is when I'm trying to defend my company against, let's say, uh, let's suppose that happened a big attack about Log4j, as you saw last year, if I'm not wrong. Okay, big attack about Log4j. We spend a lot of time doing research about Log4j, but your company, they don't have any application using Log4j. You see, like the time is important here. So to emulate things for the security perspective, and that's the thing. So how is my business? How is my organization? How is my architecture? I need to know about my architecture. How I can protect my architecture if I don't know anything about, or if you're blind spot, if you're hiding spot. So that's important thing to map. And after that, I can try to emulate things. And when you emulate, try to elevate, let's say, the level. What's that mean, elevate the level? I can use, let's say, bunch of libraries, open source. I can put in, let's say, the APT 19, APT 42, and I try to run this emulation campaign. But it's like this campaign is for, let's say, electricity companies, and my company is for oil and gas. Like it's different, you know what I mean? So that's the second level. So try to emulate realistic thing against your proper business. So that's my advice to you, Patrick, and the guys. Cool, man. Cool guys. I think yeah, I think it's we finish over here. I'm closing everything here. I can see you guys here. Cool. So I think I just would like to say thank you, Nora and the iExperts for inviting me, for having me here again. And guys, I share with you my, LinkedIn, my Instagram, my Twitter. If you have any questions, if you're in shame here, you can ask me on other social medias. And thank you for being here until now. And I hope to see you soon in the next webinar or the next event. I will be participating, by the way, at the RSA. My next event will be RSA in March, before I go to Brazil for another event. And I'm hoping to go to Dubai for JISAC. I'm not sure. It depends on the organization that we're running for these bad situations that are happening right now. But I will be participating in a few events. So if you saw my social medias, you can try to reach me out in that. And those events will be a pleasure to meet you in person. Okay, good to talk to you guys, and I hope to see you soon. Bye bye. Have a great rest of the day or the night, depends where you are. See you soon. Bye bye.